So, what can I do? Well, definitely I need panels, but do I need long panels or short panels? Let me be a little bit, well, let me talk briefly about a related problem, which is pretty much the same problem that I was describing across households also takes place within households. In other words, everything I say about various households within the village, you could say the same within the household. Assume that part of the marriage agreement is about free sharing, or actually maybe it's not. Even if it's not the goal, it could be a byproduct. But the fact is, we know that people share risk within the household. Well, it turns out that the mere definition of the utility of the household then is problematic, because even if we assume that everything is that's going on within the household is efficient, we still have those Pareto weights, and those Pareto weights depend on the characteristics of the distribution of respective incomes. So whenever you get something that's correlated with those distribution, it has an impact on the Pareto weight, which means that it generally has an impact on the shape of those utility functions. So it's even worse than what I said here. Here I was talking about the marginal utility of income, but you cannot even define the marginal utility of income because you cannot even define the utility at the household level. You can define something at the household level, but the shape of this utility in general will depend on the Pareto weights, therefore on the characteristics of the distribution of the functions. So that's the nature of the task. So what can you do? Well, in general, when you have a problem like this, you have to go deeper into the theory. And the way you do that is, well, actually it has been done in two ways. In the literature, there is a paper. So that was Mazzoco's PhD dissertation here. When is it the case that despite the fact that there are two people in the household, they share risk efficiently, they behave as if there was a single person? When is it that we can assume that there is only one person, even though there are two of them? And there we have a precise answer to that. We need harmonic absolute risk aversion, meaning that the coefficient of absolute risk aversion is 1 over a constant plus another constant times income. And in addition, this B should be the same for everyone. So in particular, the important insight here is that if we have constant relative risk aversion, so utilities like this, which is a particular case of this without the A, then the B should be the same for everyone. So if you use constant relative risk aversion, which is by far my favorite approximation of utility function because it fits the data extremely well in a bunch of further application. But if you want this plus a representative consumer, you need to assume that all people are identical. Now, many papers use this, make this assumption that people have identical risk aversion, and then makes your life much easier because what you can show is that in that case, the consumption of each household or each person within the household, for that matter, is a fixed proportion of total consumption, the proportion being, of course, a function of the Pareto weight. But when you have this, you can take the log and take the differences in log, you get rid of the Pareto weight. So if you believe in this kind of model, here is the regression that you should run. You should not regress consumption or total consumption and income, because that's spurious. You should regress variation in individual consumption over variation in log, individual consumption, over variation in log aggregate consumption. In this regression, everything, all income variables should be insignificant, and in addition, the coefficient should be. And this is done in a bunch of papers. Recently, in a very nice paper by Chris Yuki, editor before Chris Yuki. Now, the problem is, there is a price to pay, which is you need to assume that people have identical preferences. And can we do better? Can we do without this assumption? And the answer is yes. Now, it turns out that I deeply dislike the assumption that people have identical risk aversion, just because it's completely counterfactual. I will show you the numbers in a minute. But I've done a lot of work on estimating the distribution of risk aversion. And every time you try to test the silly assumption that people have identical risk aversion, it's rejected at levels which are the absolute record of levels of rejection I've found anywhere in economics. I'll show you numbers that we do on this stuff. And let me forget about. So what we do, and I won't be precise about this, but the paper is available, is we work out a way we work out a way to look at this problem of efficient risk sharing in a situation in which we take constant relative risk aversion, but we allow for heterogeneous risk aversion. And the reason why we're able to do that is that we have long panels. In Rob's data, we follow each household for something like 90 periods. So with 90 observations, there are plenty of things to do. Let me just give you, for those of you who are familiar with this kind of literature, this is the program that we're maximizing, right? These are the first order conditions, and lambda t here is the Lagrange multiplier of this constraint. So it's something like the social value of consumption. It's something that reflecting the fact that in some situation there's plenty of food available, plenty of resources available, so the marginal value of one additional unit of resources is pretty low. Whereas in other situation, you don't have enough food for everyone, and then the value of food, the marginal value of food is very high. That's exactly this marginal value, the shadow value of resources is this lambda t. So then you have a very nice expression in which you got the log of individual consumption, which depends on three things. This marginal value of resources, which is defined at the collectivity level, not at the individual level. Then you got the Pareto weight, and then you got the risk aversion. And that's what we take to data. Now, if you're following me, you should be surprised by something, namely, I'm telling you that I'm going to run a regression, and the left-hand side I observe, but there are three variables on the right-hand side, none of which I observe. I don't observe individual Pareto weights, I don't observe individual risk aversion, I don't observe this lambda. I might observe total resources, but then the shadow price of those total resources, that's something I don't observe. So that's an interesting empirical concept. I'm regressing the left-hand side that I observe on the right-hand side that I don't observe. Well, but you can do it. You think of it. This is spatial data, so you got two-dimensional I and T. Here, think of all those guys as particular parameters. And let's assume you have 100 people over 100 Pierre, right? So the number of observations here is 10,000. How many parameters do I have? I have 100 here, 200, 300. That's a model which is vastly overdetermined. I can certainly try to get an estimate of those numbers, up to something. And actually, all the theory we do in the paper is to explain up to. For instance, it's very clear that if I multiply each lambda by 2, that I divide each, and I multiply each mu I by 2, this stuff doesn't change. So it's up to something, and all this is worked out.